For as long as we have been human, we have looked up. For as long as we have been human, we have looked up. We have stood under the vast, dark canopy of the night sky. We saw a blanket of countless tiny lights. We watched the slow, steady arc of the moon. We saw certain bright lights wander against the fixed backdrop of stars. These were the planets, the wanderers. Our ancestors drew lines between the stars, creating pictures in the sky. They made maps of the heavens. They told stories about these celestial beings. And in the quiet moments, they asked simple, profound questions. Who are we? Why are we here? Are we alone? In those ancient times, it was natural to think that Earth was special. It felt like the center of everything. The sun appeared to rise and set for us. The stars seemed to be tiny jewels placed in a great dome above our heads. This idea was comforting. It gave us a sense of place and importance. The universe was our home, built just for us. The Earth was the stage, and everything else was just scenery. This perspective shaped human thought for thousands of years. It was a story we told ourselves, less lonely, a little more understandable. But what if that story was incomplete? What if Earth was never meant to be special? This question is not meant to make us feel small. It opens our minds. Imagine the universe not as a single room with us in the center, but as a mansion with countless rooms. Perhaps our room is just one of many. Perhaps there are other rooms, with other inhabitants asking the same questions. This thought carries a deep sense of wonder. It suggests the cosmos is not just for us, but for all life that might arise within it. The journey to answer this question is one of humanity's greatest adventures. It is a story of curiosity, of looking closer, and of changing our minds. It is a journey that began with our own eyes, and it continues with instruments that extend our senses across space and time. For centuries, planets around other stars were just a theoretical idea. We could not see them. Small, faint, lost in their star's glare. In the last few decades, that changed. Using clever techniques, we began to find them. The first confirmed exoplanet around a sun-like star came in 1995. It was a watershed moment. The question shifted from if to how many. We now know thousands, and we find more all the time. We have found a stunning variety of worlds, planets orbiting two stars at once, like Tatooine, and planets roughly Earth-sized, some in the habitable zone, where liquid water could exist. In 1961, Frank Drake framed our ignorance with the Drake equation. It does not give a precise answer. It multiplies questions. How many stars form each year? How many of those stars have planets? On how many of those planets could life arise? How often does that life become intelligent? How many develop detectable technology? And finally, how long do they last? It organizes what we do not know. Thanks to Kepler, we know planets are common. Most stars have them. Potential homes for life number in the billions, perhaps more. The raw materials for life might be everywhere. So yeah, the possibilities are, well, enormous. If the universe is full of planets, where is everyone? As Fermi asked in 1950, where is everybody? The universe is ancient. Our galaxy has had eons for life to arise. If civilizations are common, we might expect signals, probes, or megastructures. Yet the cosmos appears quiet. The great silence invites many possibilities. Intelligent life may be rare, distant, silent, or short-lived, so the universe can appear empty, even if it is not. When we think of life on other worlds, our imagination defaults to what we know. We picture creatures like us, or like Earth's animals and plants. But life elsewhere might be completely different. On Earth, life is resilient and adaptable, even in extremes. Microbes thrive in boiling vents, far from sunlight. Life survives deep within the crust, living on chemical energy from rocks. It endures in intense salt and bone-dry cold. Some bacteria withstand massive radiation. These, extremophiles expand our definition of life. Life needs energy, liquid water, or another liquid, and essential elements. Those conditions may exist in many more places than we once thought. Our search does not have to span light years. Mars is our closest, most studied neighbor. Today, it is a cold, dry desert world, but long ago it held rivers, deltas, and vast lakes. Minerals reveal persistent water. Mars once had the ingredients for life as we know it. If life began there, it was likely microbial. Its fossils may still be hidden in rock. Our rovers drill and analyze, searching for signs of past life. If surface life is gone, it may persist underground, shielded from radiation. Future missions will look deeper for a hidden biosphere. One fossilized microbe on Mars would prove life is not unique to Earth. Europa is covered in ice. Beneath it lies a global ocean, possibly more water than Earth's. Tidal forces keep that ocean liquid and active. Hydrothermal vents there could fuel rich ecosystems without sunlight. Enceladus jets plumes of ocean material into space. Cassini tasted water, salt, silica, and complex organics. A future mission could analyze those plumes for signs of life, sampling an alien ocean from orbit. What if life exists, but not the way we expect? Next-generation telescopes and SETI programs push our search forward. We are learning to look for life not as it must be, but as it could be. Let us imagine the search succeeds. One day, a signal arrives, or a rover finds definitive proof of fossilized bacteria, or we detect the chemical fingerprint of a distant biosphere. If we discover we are not alone, will it change the universe or change us? It could unify us, redefine our place, and drive scientific innovation. We stand on a small world, asking, what if we are not alone? The answer will change us forever.